Hello students, in today's session we'll be discussing about the word count using MapReduce. Well, you might have seen other videos wherein I have discussed about MapReduce, how exactly it works, okay, the theoretical concepts, what all things we need to understand. So we are trying to understand here the basic concepts with a model, an example, and also the practical implementation of it. That is what I'll be discussing in today's session. In another video, we discussed about the MapReduce, its functions, okay, with an example about the word count itself, right? But here, the difference is we'll be talking about the programming concept, that is how you're going to write a program, what all things are involved in it. Yes, so I would be taking up an example, of course the word count example, and we'll be talking in terms of practicality. The practical terms, okay, will be highlighted and we'll be proceeding on those lines. So with that, we'll start with the word count using MapReduce concept. Now, typical problem solved by MapReduce, of course, what we have here is read a lot of data. That is the first and major point which you need to understand. So map, extract something you care about from each record, shuffle and sort. So what you are trying to do here is you are trying to implement the first set of operations. Extract something you care about. So what we need to understand here is what are the major details we need to fetch, how you are trying to sort and shuffle them. That is the first part what map does. Next we have reduce. Of course, reduce is basically where we talk about aggregating, summarizing, filtering or transform and give the results. Now in these two particular points, what does the map do is we are talking about each and every node present in a Hadoop cluster. Okay, so you can just imagine, I'm not talking only about a single node. We are talking about the number of nodes which are present or which are working for this particular task. I hope you're getting this point. Yes, when I'm saying that, we are not talking only about a single node. We are talking about all the nodes which are specific towards the particular task which we are working on it. So we are talking about multiple nodes which will be present here. Now, this is the first set of point. Now the next thing is the data flow, how exactly we are trying to work with that. So mappers read from HDFS, the first point you need to understand. Then map output is partitioned by key and sent to reducers. Now this is where we break into the main aspect of logical part, the logical thinking. Okay, how exactly you are trying to work with that. What is happening here? Mapper is reading file. We are having a file. That file is in HDFS, and from that HDFS we are trying to read some input files or the data or the records or the large data set, whichever you take. Of course, large is very important. So we are talking about the first one, to read from the HDFS. Once we read it, what is the pattern which you are reading it? Isn't it? Because I just told you that we are trying to have a particular map and the mapping is taken from input file. We are trying to work with that function and then it moves on to the next, that is combine, then shuffle, sort, and then to the reduce function and finally the result. So we are talking about the intermediate results which you want to generate. Okay, so how exactly you are talking about the data which you need to fetch? How you are trying to divide that? How you are trying to understand that data? Okay, because if you want to read something, you need to know how well a data has to be read. And if you want to read it properly, well, there should be some pattern. Okay, now it is partitioned by key. So this is a major point which you need to understand. So here it says that there is a key value pair in which you are trying to read a particular data. Okay, so it may be a particular document, okay, which is in a URL. So URL, and they are talking to work with the documents and then trying to get the details. So key is the URL, value is the document present in that URL. Okay, when we talk about the web page. So when you're talking about the input file, whatever is there in it, okay, there will be a key and a value which you need to fetch. Key will be the file name and the values which are presented. Okay. Next, reducers sort input by key. So key value pair, as I said, plays a very vital role here. And the vital role is that to work with the partitioning of it and also the sorting of it. So it becomes easy when you pick up a or particular fetch the key. Okay. So in an input file, what happens? There are set of words. So the set of words are the keys and the values are the number of occurrences. That is how we are talking about the in-depth detail. Are you getting? So basically what we say here is the reducers and the map function work on the key pair values. Okay. K and B. Reduce output is written to back HDFS. Well, in the next slide, I will be giving you the detailed structure, how exactly it works with the particular node, what you have seen in the HDFS architecture. Okay, so I'll be reflecting the HDFS architecture here and exactly telling you how it works with the following example. Okay, before that, this is the overview. Okay, you can see here, we have an input. There are two inputs, there are mappers, there are reducers and HDFS. So this is the first particular point. You can see what is happening here. So we talk about input, map, sort, reduce and output. There's another part, another node which is working on it. Okay, there's another input from that. So what is happening here? Once it is mapped, it will be sorted according to the pattern, what we have designed. Okay, so the multiple nodes which are having all these particular tasks will be sorted and combined. Okay, so once we do that, we are trying to work with the shuffle and then the reduce part will try to do the remaining job for us. This is how the whole scenario works. Okay, now, so as I said, we are talking about input, we are talking about the map and sort. So these two particular points are being helping us to sort with the help of a key. This is how the whole scenario is being implemented. Okay, so after that, it's a common reduce, shuffle and reduce part which will be done. Now, as we have these four steps which are mentioned here, okay, right from this and the particular, we'll try to understand it in more detail. Okay, now, as you see this particular diagram, okay, well, I'll be sharing you this PPT. You can look into the PPT and try to work out. Okay, now, detailed Hadoop MapReduce data flow. So what is the concept here? We are talking about the Hadoop MapReduce. There are two particular nodes which are being provided. This is one node, this is another node. Okay, now we'll go step by step in it and check what all things happen here. Okay, so we have the input file from the particular client and we have the input format. Okay, the name nodes which will be working. So files loaded from local HDFS stores. So the files are here on the name node which will be sent to the particular input format. So you can just imagine how the particular earlier steps are being described in detail. Okay, so the input file will go to the input format in which you want to fetch it. What was the earlier example when we tried to understand each and every word in it. So each input file will be taken as a single line and proceeded. Okay, here we're talking in a key and value pair. Key value pair is being implemented and then considered. Okay, so we take it into the input format. After that, we try to split it. That's what the step is, right? So once you take the input, the next immediate step is splitting the particular file in a particular way. Okay, so splitting it in a key value pair where we try to understand how it has been done. So suppose there are words like hello, welcome to Hadoop, welcome to MapReduce. So there are two statements. So welcome to Hadoop is one, welcome to MapReduce is another one. Okay, so these two particular lines will be split into words. Okay, we'll talk about welcome to Hadoop. That will be the first. Okay, I'll tell you in that part also. Next, welcome to MapReduce. Welcome to MapReduce. This is how it gets splitted. Okay. So these are the record readers, RR. Okay, so RR are the record readers who try to split and check whether the record what is there is properly read. All the record are being considered. Okay, that is what is the point. After that, we map it. After these two steps, that is splitting and reading all the particular data from that recorder, we have this into a particular pair now. Okay, so once we split all those welcome to Hadoop, welcome to MapReduce, we start mapping them. Okay, so welcome to Hadoop. This is the first set of points. Okay, then welcome to MapReduce. This is another. So all these are mapped in a input that is K, V pairs. So this is where the particular point of input starts working. Okay, the actual input which we need to start working on it. So this is the mapping function where we talk about the following input key value pair. Before that, only the statements are considered, others are split and understood. Now, once we come across this, we try to partition it. Okay, after the mapping function, we try to partition it in according towards the pattern which you want to design. Okay, so when I'm talking about a particular word count, what we need to do here is we talk about the partitioning it in a particular format. That is welcome. Okay, then to, then Hadoop. That is the first set of partition. Then welcome to MapReduce. So welcome is coming twice, to is coming twice, whereas Hadoop and MapReduce are coming only once. That is the partitioning which is happening here. Well, the same we talk about here. What is another node having? The same set of points, but here also may be certain set of values. Okay, that is the word count what you need to work. So we are not talking only about a single file which is working here. Okay, from a particular node. There are multiple files here and another node. There are again multiple files there, and that is how it can work. So large data set. That is the fascinating point which you need to understand here. Okay, now, so what it says, we are talking about another particular node in which we come across the same sort, split it, record reader is there, map it, then we have the partitioning of it, and then after that, suppose there is another file where again we have written there, what is that? Hadoop MapReduce example. Okay, that is another point, another statement. Okay, then I am saying again one more term, that is MapReduce is a very important, what is the framework that may be there. So MapReduce, whatever is there will be having a particular key value which will be again shuffling process. This is what happens here. Okay, so that is the major point what after partitioning we are trying to sort here, and this is where the intermediate key value pair will be generated. Okay, so this is what happens. Intermediate key pairs exchanged by all nodes which are having a particular task which has to be specific and has to be worked out. So this is a very important step in the MapReduce. Okay, so if you take multiple files and work on it, well, this is how the whole thing will be designated. They will be partitioned and they will be assigned according to the specific task. So we are trying to shuffle it. This may be having a particular point, design, it works there, MapReduce will come here and so on. All these things will be done. So once we sort here, next is what? We are trying to send the final key value pair to reduce function. Okay, so the reduce function will do what? It will just aggregate, summarize, filter and give you the actual data. Okay, so what I said here was, let us take the example, welcome to Hadoop, welcome to MapReduce. Here I said MapReduce is a framework, important framework. Okay, so MapReduce from that particular file also will be clubbed here because I am talking about in a file how many times a particular term has been occurred. Okay, so MapReduce will be here twice again, but Hadoop will be only once, whereas is a very important framework, will be all once. Okay, so this is what is the point you need to understand. Okay, so this is what the reduce part will do. The final key value pair KV will be considered in this format and you get the output. That is the number of occurrences of each particular term or word which has occurred. We count it and we try to provide. Okay, so the key is what? The words itself, and the value is the sum of it. Okay, the value is the sum. We are talking about the number of occurrences. That is what you need to calculate in the reduce and generate it. This is what happens in the whole detailed Hadoop MapReduce data flow. Okay, so this was the point I wanted to just tell you. So the last part here is output format is there, which will be sent back to the HDFS, which says that write back to local HDFS store. So again the file will be in the HDFS. So when I say HDFS part, of course we are trying to get it into the particular way. So you will not be having any particular output in a text file or any of this, right? It will be in a binary format. You need to generate that. Okay, so we have to check in HDFS, we need to just find out, store it in a text file and then generate it. Okay, so this is what is the point. So you need to fetch it from the HDFS. Okay, now moving on to the next, we'll talk about the programming aspect, how exactly we're trying to work with it and generate. So the basic data type what we need to work out with the MapReduce paradigm here is the key value pair. This is what is the important thing you need to look out. So for example, we have taken here key is equal to URL. So the value is what? HTML of the web page. Okay, so what is that? So you are providing a particular URL and that URL will be consisting the value as HTML code of that particular web page itself. That is what is the example. So programmer specifies two primary methods. The two primary methods which will be taken care, that is map and reduce. Okay, so map will be having K and V, so reduce will be having also K and V, but slight change here is we talk about K and V and we'll be having a set of pairs. Okay, you can see K1, V1, K2, V2 and up to K and Vn. Whatever input file the data is, we are trying to fetch it in the map. And then we have K dash in which a particular set of values are there, which will be considered as K dash, V dash 1, K dash, V dash. So the output will be in this format. A particular key and its value. Okay, that is what the reduce will be performing. Next, all V dash with same K dash are reduced together. Remember the invisible shuffle short step. This is what is the point which happens in the intermediate part of it. Okay, so with this we will be understanding how exactly the whole programming aspect has to be worked out. Okay, so we'll go with this point here, that is shuffle. Reducer is input, the grouped output of a mapper. In the phase, the framework for each reducer, it fetches the relevant partition of the output of all the mappers via HTTP. Okay, so you might have come across this HTTP in the HDFS architecture in where you talk about the file system. That is what is the point you need to. Sort, the framework groups reducer inputs by keys since different mappers may have output the same key in this stage. So what is happening here? The different mappers from different this, we need to sort it, we need to pick it up. The shuffle and sort phases occur simultaneously. That is, while outputs are being fetched, they are merged. So this is what is the point which is very interesting here. Okay, so from different nodes when we are trying to shuffle it, as it is shuffling, it is trying to sort it. Both the things are happening simultaneously and you are trying to get the intermediate results. Okay, so we'll just check here, input, files with one document per record. Okay, so we consider this as a particular file with one document per and having a single record in that. So specify a map function that takes a key value pair. So key is what? The document URL. Value is what? The contents of the documents. Okay, so how exactly we try to understand, we'll just see. Output of map function is potentially many key value pairs. Of course, it has to be because we're talking in a large data which you work. In our case, output is what? Word and the value 1. Okay, once per word in the document. So you can see here an example. So document 1 is the key, to be or not to be. So what is happening here? We are trying to split them. Okay, the values are to be considered in this format. So 2 is 1, B is 1, or is 1, not is 1. Then again we have 2, 1, B, 1. Initially we just try to split it. Okay, we do not directly work out, because this is one document. We need to consider the documents which are considered for this whole task. So there may be many documents, okay, and each document has to be worked out. So there is a specific task which has to be done with this. So this is what happens here. So basically the output of map function will be in this format, that is word and one. Remember that. Now, MapReduce library gathers together all pairs with the same key. Okay, so having the same key, what does the MapReduce do? It gathers them at one place. At one particular point it tries to integrate. So specify a reduce function that combines the values for a key. In a case, compute the sum. Well, that is what you have to work out with the basic logic. What we are doing here is we are trying to work with the word count, the occurrence of a particular word. So how will you work out with that? You will try to first check that word. If it is appearing again, you just go on adding it, the sum of that. So you just see here what is happening. Key is equal to B. So you can see here how it has been split into the, so initially we took the document per record. After that we are talking about the key value pair. Okay, from each particular file, okay, a document, okay, in that the content. So the contents have been considered here. So key is equal to B, value is equal to 1. Okay, so key is equal to B, value is equal to 1. Then key is equal to not, value is equal to 1. So what happens? B, to be or not to be. How many times it occurs? B, twice. So we are having it 2 times. So values are 1 and 1. Or is 1, 2 is also. So this is what you get, 2, 1, 1, 2, which has to be considered. So I get B is equal to 2, that is the key value, B and 2, not 1 or 1, 2. So what it says, output of reduce usually 0 or 1 value paired with key and saved. So this becomes a very simple task here now, right? So you have the contents, that contents have to be done in a key value pair. That is to be or not to be and assigned in this fashion. Okay, so the output of the reduce will be in the similar fashion with 0 or 1 value. So once that is done, okay, that gives you the clear idea about how exactly it works out. Okay, how the key value pair is done, how you are trying to consider the key and the value and get the final result. Now we'll go with this in a more detailed part, that is by understanding the details about the program. Okay, how and what happens. A MapReduce paradigm program consists of the following 3 parts. So in a programming aspect, of course in a Java program, we'll be using a Java program and trying to perform it. We'll be using the driver, that is the main program, would trigger the map and reduce methods. So you're trying to work with the methods. Okay, so we'll be talking about the methods like mapper and reducer are another class, interfaces which will be done. Okay, so the methods are map and reduce, and mapper and reducer are the another interfaces which has to be taken. So these are the 3 main parts which you need to understand. One, that is the main, that's the driver. Okay, driver class. Then we have a mapper class and we have a reducer class. Okay, that is what is the initial point you need to work with. So I have here a particular set of code. Basically we'll be discussing in detail about what exactly we are talking about. So you might have come across these particular points in the Hadoop ecosystem when we talk about the file system and the commands, and also the packages. The packages, the IO packages which are used for the program, the Java. Okay, so it says like mapper, public static class map extends MapReduce base, implements mapper. So here we are talking about the interface, that is mapper. We are trying to implement it. Okay, so it's an interface. We are talking about the interface which will be doing the particular job for us. Okay, so map extends MapReduce base, okay, and which implements the mapper part. So MapReduce base is the, well, I need not tell you that because we are talking about the class inheritance. Okay, map extends MapReduce, and then we are talking about the implementation of the mapper. Now, the next point what you need to understand here is basically here, private final static int writable 1 is equal to new int writable. So what is int writable? We are talking about a particular writable part, that is an integer part. Okay, so we are talking about that final static. It is declared as private final static. Then we have private text word is equal to new text, so that we can have a particular text which can be worked on it. So basically, variable is trying to convert a particular what you can say text into the string and then the particular format. Next we have public void map, we have long writable key, text value, output collector, reporter, and an exception which is to be caching it. Now, this particular map is the method which is going to have the following parameters. Long writable, okay, what it is, text, okay, what it is that, output collector, trying to just have the output there, and the reporter just to report whether we are trying to work with the proper things or not. Okay, I told you in the concept, like how exactly you need to monitor it. There are certain particular functionality which has to be monitored, so you have to report it. That is, so string line is equal to value dot to string, just to work with the strings option, or you are trying to convert that. Then we are talking about the string tokenizer. So tokenizer is a very important keyword here, because we are talking about the key value pair. We are talking about the tokens which are to be carried out. So you are trying to assign the tokens to each of the key value pairs and trying to work on it. That is what makes it very simple. We are trying to divide it. Okay, so each of these are being tokenized, and the tokenizer has been identified and performed. New string tokenizer is a line. We are taking out particular line and trying to tokenize them. Okay, token. So while tokenizer has more tokens, we are trying to just have the word which has to be set. Okay, and output collect will be word and one. We are just talking about the particular word which has appeared, and we are trying to assign it as one and going on adding in the later part of it. So let's check. Excuse me. So what happens here in mapper explain is map class header. So basically we talk about the first class header having the MapReduce, that is extends, then implements mapper, and we have the long writable, text and int writable. So it is all explained here. So extends MapReduce base class for mapper and reducer. So what is happening? MapReduce base is actually the base class for mapper and reducer. And then the implementation, so provides default no op implementation for a few methods. Most non-trivial applications needs to override some of them. So that is why the implementation is to be taken care. So example what? Implements mapper. So how exactly it works out with the mapper implementation? We see here interface mapper, and we are having the key value pair K1 V1 and K2 V2 has the map method. So this map method is actually what you can see, long writable, then a text, then again a text and int writable. Why int writable? Because we are talking about the integer value, isn't it? So K1 V1 will be the input, K2 V2 will be the output. Okay, that is what is the first pair is the input key value pair, second is the output key value pair. Now comes the major point. The data types provided here are Hadoop specific data types designed for operational efficiency, suited for massive parallel and lightning fast read write operation. So what is happening? Long writable, text, int writable, all these are the Hadoop specific data types. Okay, so why we use this? For operational efficiency and suitable or best suited for massive parallel processing, MPP. Okay, so read write fast operation should happen, that is why you are using this. All these data types are based out of Java data types. Okay, so it is what you can say, it has been upgrade, you can just say extension, it has been brought from the Java data types itself. For example, long writable is the equivalent for long in Java, int writable for int and text for string. This is how it has been described. Long is basically equivalent for Java, right? So long writable is used in the Hadoop specific. Here we use int writable for int in Hadoop specific, and last is text for string. This is what is the initial description for the part of it. Next, we can see here Hadoop supported data types for the key value pair. Okay, so we are talking the first comment. Hadoop supported data type for the key value pairs. Private final static int writable 1, private text word. These are the data types which are Hadoop supported. Okay, so map method header. So this is the map method which we spoke earlier also. That is one. And the data type of the input key and value of the mapper is long writable key, text, value. Output collector will be having text and int writable. That is, output will be the collector key, k and v. So collect data output by either the mapper or the reducer, that is intermediate output or the output of the job itself. So that is what is the output collector doing. Okay, so key and v are the output, key and value from the mapper. Example, that is the word and the value, the and 1. To be or not to be. Okay, 2, comma 1. That is how the values are. So the reporter, what does it do? The reporter is used to report the task status internally in Hadoop environment to avoid timeouts. That's what I said. We need to monitor the operations, the functionality, how well they have been done. So to work on that, the reporter will just try to give the status. Okay, the status of the task, how exactly it has been implemented. So this is what is the point to be taken care of. Next, we have the public void part of it. Then we have, of course, we have discussed this reporter up to here. We move towards the next, that is the string value to string. So what does this do? We are talking about a particular text type to a string. So a conversion. So conversion of that particular has been done and you are trying to implement it. That is what is the point. Then we have a particular tokenizer. So that we use this tokenizer to split the line into words. So I said we are taking a statement. Welcome to Hadoop. Welcome to MapReduce. So that line is to be separated. So the tokenizer is being utilized for that. So that is what the string tokenizer, is new string tokenizer line is considered. Next, what we have to do is we have to just see until the whole statement is being captured. Okay, we are trying to traverse the whole statement. Welcome to Hadoop. Welcome to MapReduce. So these are two different statements. So first one, welcome to Hadoop will be going. So that is why we are using the while loop. Okay, so assign each work from the tokenizer of string type to a text word. That is what we do it here. So the set method is trying to set what? It is assigning. Each work from the tokenizer of the string type will be assigned to a text word. That is what we do it here. Then form key value pairs for each word as word, comma 1 and push it to the output collector. So you can just see how meticulously we are trying to understand here. Okay, so we are taking a key value, okay, trying to first split it, each of the words in a statement, pick up each of the words. Okay, after picking up, you are trying to assign it in a particular key value pair. After assigning, you are trying to send it to the collector. This is what happens here. Now, after that particular state, we go towards the reducer part of it. Okay, because output.collect word 1 will give you the intermediate result. We get a particular welcome to Hadoop, welcome to reduce will be assigned in this particular format. Now, what happens in the reducer part? Class header similar to the one in map. Okay, so class reduce extends MapReduce base, implements reduce. We have text int writable, text int writable. So here what we do is we are just trying to fetch it into the text and int, the word and the value 1. Okay, so that you are just trying to sum it up. Reduce header similar to the one in the map with different key value data type. Okay, so reduce header similar to the one which is there already. Then data from map will be this way, word and the number of occurrences of those value 1. So we get it with an iterator, so we can go through the set of values. So what is happening here? Very simple concept. Public void reduce is the method, text key iterator is the iteratable value, so that we can iterate all the number of values which are been generated, which have been collected or shuffled and sorted. Okay, So output collect the text enter. So here we get the final one, the text and the value. So output and the reporter again to check it. Now what happens here? Initialize the variable sum as 0 because we want to have the number of occurrences. Then while values dot has next method. So until it has values, we are just trying to iterate, go into that, and we are just trying to sum it up and get the value. So push to the output collector the key and the obtained sum as value. And this is what is the final output dot collect key new iteratable. The sum of that will be the point to be noted. So whatever answer you are getting for that particular value will be stored in this particular part of it. So this is how the whole scenario has been implemented. Okay. Now, after looking at this, we come towards the main. Hope the earlier concept is clear. As I said, we are talking about the value, we are talking about the sum is equal to 0. Then you are trying to take each key and the number of values, how many times it has occurred. Okay, the shuffle and sort function will be done by the background, HDFS. Need not worry about that. Hadoop will be doing it. So this is what is the point. Sum plus equal to value dot next dot get. So until the value of all those are calculated, it gets the values and it provides the final result. Now comes the last part, that is the main, the driver class. Given the mapper and reducer code, the short main starts the map reduction running. So this is where the actual whole stuff will start off with. Okay, the Hadoop system picks up a bunch of values from the command line on its own. So very important statement. The Hadoop system picks up a bunch of values from the command line on its own and starts working with it. Then the main also specifies a few key parameters of the problem in the job conf object. That is a job configuration object. This is a very important thing to be taken care. So it is a primary interface for a user to describe a MapReduce job to the Hadoop framework for execution. So job conf is a configuration which will help you to primary interface for a user to describe what exactly the MapReduce job has to be doing. Okay, to the Hadoop framework. Okay, such as what map and reduce classes to use and the format of the input output files. That is the point which happens in the object job conf. Okay, conf. So here actually it tries to tell what is the pattern. Okay, you are designing it, that is the word count, and you are trying to get the number of words. Okay, occurrences. Other parameters, that is the number of machines to use, are optional, and the system will determine good values for them if not specified. Even if it is not specified, the system will try to define it. Then the framework tries to faithfully execute the job as described by the job conf. So the job conf object is a very important critical part of it because it is giving you the problem definition. It is trying to give you the detailed information which is necessary for the job or the task to be completed in this particular format, in this particular fashion. That is what is the point to be taken care. Okay, so assume we did the word count on book, how many of the and one have as output, then share with other machines. Solution, what we do is, so here we have to assume that in a book we are trying to calculate the number that is the. So you can just imagine there is a book. Okay, let us consider the book which you are using. In that you are trying to come across the result, that is the occurrences of the word the or the, what you call it as. So solution, we can perform a local reduce on the outputs produced by a single mapper before the intermediate values are shuffled to the reducer. So this is a simple com. Okay, this is a simple format. We can perform a local reduce on the outputs which have been produced by the single mapper and complete the task. Next, what we do is combining them. So a combiner class as a mini reduce used when the operation is commutative and associative. Example, median is an example that doesn't work. Sum is commutative and associative. So what happens? Commutative and sum, you are trying to add it up and it can be commutative as well as associative. That is the rule which you need to follow. Okay. So machine A emits the one, okay, machine B emits another key value pair. So what does the combiner on machine A emits? It emits key value as key is the and value is 2 because it has occurred twice. This value along with the another part of machine B, that is in the machine B also emits another key value. Okay, will both go to the reducer node. So this will go to the reducer node. We have now saved bandwidth but preserved the computation. That's why I showed you the example initially, that why the two different nodes are taken in this format and how the partition is done and how it works. That is what we are talking about, the expensive IO which has been reduced. Okay, so this is what is the point. So you are trying to preserve the computation and you are saving the bandwidth. Okay, because they are doing all on their own and just sending the key value pair. You're just getting the inputs, nothing apart from that, no computation, nothing required. Okay, so reducer is the one which does this. This is why our reducer actually reads the value out of its input instead of simply assuming the value is 1. So this is how it completely tries to figure out what all things are being done. Okay, so that's how it makes it more interesting. Hope the points which I have discussed here are very helpful in understanding. Okay, so we come towards the last part. So public void main, that is where we start with the main function. Okay, throws exception. So job conf object is created. Why we created the job, you know that, for identification purposes, what is there in that. So conf dot set job name as word count. So we are trying to work on that. Okay, setting configuration object with the data type of output key and value. Then map and reduce if you have different type of outputs. There is other set method for them also. So this is how you are trying to implement it. Okay, so set output key class text dot class, then set output value class. This is another method of that object, wherein first we are talking about the text, adding the key value pairs. Key is in this and the values int writable dot class. So all these are differentiated in this format. So what happens? Providing the mapper and reducer class names. Next, so set mapper class map dot class, set combiner class reduce dot class, set the combiner class, and last is set reducer class reduce dot class. This is what you are trying to implement. Okay, so I am talking about the particular classes which are being generated and I am calling them as argument. Okay, and I am working on these particular set. Okay, so the default input format will be text input format. Will load data in as long writable text pairs. Okay, that's what we discussed. Long writable text will be the input part and the output will be text int writable. The long value is the byte offset of the line in the file. Next, what you do is the text input format dot class will be helping us to get the format in which you want to work. So how it is divided part by part in the following. So mapper will not just be working, it will be having all the details. So the necessary information have been assigned here. So we have an input format, similarly we have a output format also. Last comes is the file input format to set input paths. Okay, so the HDFS input and output directory to be fetched from the command line. So fetch from the command line, we give new path args arguments. One for the input and one for the one for the input and one for the output path, and last we have the job client which will give us the run job method. So the object what is there will be actually completing the whole stuff and which will be returning the completed job to the HDFS. So this is what is the following sort of points are considered. Okay, with this we'll stop here. Okay, the next class I will be having a practical session. The program what you have written here, okay, will be implemented and I'll show you how exactly you are trying to work with that. So the next video we'll just check out with the practical session and finish it off. Okay, thank you, take care.